Okay, so we're ready to begin experiment 23B. So in this case, we are synthesizing N-phenylmaleimide from the malianic acid that we prepared as part of experiment 24A. So for our first step, we're going to weigh out 100 milligrams of our malianic acid, and from that, we're then going to combine this malianic acid with acetic anhydride and a few other additive reagents, and then we're going to heat our reaction mixture to generate the desired N-phenylmaleimide product. So we'll pause as we weigh out 100 milligrams of our malianic acid, and we'll resume once we've dispensed the required amount of reactant. I would like you now to record the mass of malianic acid reactant that we are going to add to our conical vial. Okay, so we've combined our malianic acid, 200 microliters of acetic anhydride, and 25 milligrams of sodium acetate in our vial. We have our vial connected to an air condenser and topped with a drying tube. And what we're now going to do is we're going to heat our reaction mixture to approximately 80 to 90 degrees Celsius for 30 minutes with stirring. This will facilitate ring closure and allow us to generate the desired N-phenylmaleimide with the loss of water. The acetic anhydride both serves as an activating group to encourage the loss of water, and it's also a desiccating group. The reason why this reactions run at elevated temperatures is also to assist in the ring closing process and help drive off some of the excess water generated. So we'll heat this reaction mixture for 30 minutes, and then we'll resume once the reaction is complete. Okay, so as our reaction has finished heating for the required 30-minute time period, we're going to elevate our reaction mixture out of our heating mantle. And as you notice, there's been a pretty rapid change in the color of our solution. So what we're going to do is we're going to allow this reaction to cool to room temperature. Then we're going to add a small amount of cold water, and then we're going to place our reaction mixture into an ice bath. So we'll resume once our reaction has cooled to room temperature. Okay, so our reaction mixture has been allowed to cool to room temperature. We're then going to add 1 milliliter of water. And as you notice, as you can already see, we're beginning to observe solid product precipitating from the solution. What we're then going to do is we're going to place our reaction mixture and immerse our reaction mixture in an ice bath. And that's going to further facilitate and help precipitate out our product. So what we're going to do is we're going to allow this mixture to cool in the ice bath for approximately 5 to 10 minutes, and then we'll filter our product mixture. Okay, so we finished allowing our reaction mixture. To cool, and we're beginning to see our product precipitate out of solution. So what we're going to do next is we are going to very carefully filter our solid using a hersh funnel. So we'll get that set up momentarily. Okay, so we have our hersh funnel prepared. So we're going to collect our solid via vacuum filtration. Okay, so we've applied vacuum, And now what we're going to do is we're going to filter our solid mixture. We're going to use a few rinses with water. And now what we're going to do is we're going to very carefully rinse off the solid that has accumulated on our stir bar. We're going to continue to rinse our reaction mixture and stir bar with chilled ice cold water. We're going to rinse our reaction flask. And we're going to continue to rinse our reaction flask with a small volume of cool, chilled ice water. We're going to wash with an additional aliquot of water. Okay, so as we can see now, we've collected our purified solid via filtration. And for an additional purification step, we're going to allow this solid to air dry on our filter for an additional 5 to 10 minutes. And then what we're going to do is we're going to purify our product N-phenyl maleimide via trituration with hexanes. So we'll resume in about 5 to 10 minutes once our sample has finished air drying. Okay, so we've finished allowing our sample to air dry. So next we're going to transfer our sample to the crag tube. Okay, so now what we're going to do is we're going to very carefully transfer our solid product into our crag tube for trituration with cyclohexane. So here is our crude product, and we're going to transfer it to our crag tube. And we'll resume once we finish this transfer process. Okay, so we've loaded our crude product into our crag tube. And now what we're going to do is we're going to triturate, and we're going to add a small volume of cyclohexane. Okay, so now what we're going to do is we're going to carefully agitate our mixture. And now we're going to set up and separate our solid and liquid. To further help with this agitation process, we're going to break out a glass stirring rod, and we're going to agitate our solid with our cyclohexane. This is going to help break up our solid and dissolve any potential impurities. Okay, now what we're going to do is we're going to load our cap for our crag tube. We're going to set it up so we have our secondary conical tube. So as you can see from this setup, what we're going to be able to do is after centrifugation, we'll be able to separate our solid and liquid. So what we're going to do now is we're going to invert this tube, and we're going to centrifuge our Crag tube setup to separate our solid and our liquid. So we'll resume once we've completed the centrifugation process. Okay, so we have our Crag tube set up after centrifugation. So now what we're going to do is we're going to very carefully collect. So we have our supernate liquid that we'll collect off to the side. Okay, so now what we're going to do is we're going to triturate this solid once again with another rinse portion of our cyclohexane. Just like before, we're going to use our glass stirring rod to mix and triturate our solid. Okay, so now we're going to centrifuge this mixture and separate our product from the impurities dissolved in our cyclohexane. So again, just like before, we prepare our Crag tube setup. We, in turn, hook up our corresponding conical vial that will collect our supernate liquid, and then we invert. Okay, we'll then separate our solid and liquid cyclohexane that has rinsed off some of our impurities in our solid sample via centrifugation. So we'll resume after we complete the centrifugation process. Okay, so again, we've separated our solid product from the supernatant liquid. So now what we're going to do is we're going to very carefully remove our Crag tube cap, and we'll store the supernatant liquid off to the side for later. Never throw anything out unless you're completely finished with the experiment. So now what we're going to do is we're going to triturate our solid one last time with an aliquot of cyclohexane. And just like before, what we're going to do is we're going to agitate our reaction mixture with our solvent, and we're going to triturate our solid with our cyclohexane. So we want to make sure that we're thoroughly mixing our cyclohexane and our solid. So now what we're going to do is we're going to separate our solid and supernatant liquid via centrifugation. So we're going to set up our Crag tube cap, and we're going to add our conical vial cap. And now that we have everything securely set up, we're going to invert our Crag tube, and we'll separate the solid and supernate liquid one last time via centrifugation. Okay, so again, as always, we're going to separate our solid and supernate liquid. Okay, so we have our crag tube cap. We're going to collect our supernate liquid off to the side, just to save in the event that we have an issue with the identity and purity of our product. So now what we're going to do is we're going to very carefully transfer our solid product onto a pre-tared and pre-weighed piece of whey paper. We're going to continue this transfer process and we'll resume once we've completely transferred all of our solid. Okay, so we've fully transferred our product to our piece of whey paper. And now what we're going to do is we're going to take this to the balance and record the mass of isolated product. Okay, so I'd like you now to record the mass of isolated pure product, which is our N-phenylmaleimide. And from this data, you'll be able to calculate the percent yield for this reaction.